There were some questions on a few like shader, some shader business, so I will start with that. Maybe that could be useful for a lot of people. All right. Photoshop. Yes, I'm gonna just make a few a little theoretical intro to dot product and cross product. Just because I know before I learned what it was, I heard it a lot and I never knew what it was until a friendly programmer told me what it was. So I'll give that to you. Yeah, whatever. Okay, so the dot product is the length of a vector projected onto another vector. I'm going to try to draw that to make it more clear. All right. So this is one vector, and a vector is just like a 3-point, a collection of three numbers. Usually it could be 2D vector, two numbers, and even a 4D. But so visualize like this is like this is a origo, origo of the scene. So 0, 0, 0, and these represent like three different numbers. So they are arrows. You can visualize them as arrows coming out from the origo. So yeah, exactly. That's what it is. So the the dot product of the red one to the blue one will be this length, the yellow one. And I did two yellow ones, but I'm gonna take this one. Oops. Mm -mm -mm. So it's the projection, the length of how like if the red arrow will cast a shadow right onto like the perpendicular from like if the sun was coming this way and the red was casting a shadow on the blue one, the length of that projection, that is the dot product. um, so that can be useful in a lot of times, especially if you do lighting or if you do like directional blending. So if swatches. So if I have my directional arrow like this, and I have okay, no, try and make it clear. If the red arrow point this way, I will get a negative dot product. So I would get uh, I mean, whatever, minus something because it's on the other side of this direction. Um, did that make any sense at all? Yeah, or yeah, like the reference vector. Um, new material. Try and make a practical case. So if I'm just gonna make a direction here, make it x, for instance. So it's an x vector, and then I want to know if something is pointing in the x direction, so I make a direction parameter. Oh yeah. To make a color or a vector in here, you can just hold down number 3 on your keyboard and just click. Yeah, and then I convert it to parameter. And that's same if you want like a scalar or a float value, just holding 1 and click, and then you can right click and convert to parameter, like something. So that's very useful. It's a very good question. I do it all the time. It's a great time saver. Yeah, yeah. No, it's just 3 vector. Um, and as you may have noticed, is if you convert vector 3 to a parameter, is always going to be a vector 4, but it doesn't matter. The top pin always outputs the 3 vector, and then you have or maybe I'm lying, might have output all of them. Yeah, it does. So you get red, green, blue, and alpha here. So dot product into emissive color perhaps. Hey, let's take normal. Vertex normal, pixel normal. Pixel normal world space. So the normals that are pointing in the x direction are going to be white, and the other one's going to be black. These one actually are negative space, negative numbers on this side, and 0 is right here. Let's see. Remap value. So -1, 1, oh yeah, 0, 1. Oops. Um, oh yeah, sorry. It doesn't work because I made floats here in this vector 3, but I'll skip that. Yeah, I had to make, if I want to make this one remap, I'm not sure it does, uh, it's only scalars, so only single numbers, this one remap node. So I can't do a dot product of a scalar as a float value to a vector. So I was gonna make like a quick fix to show that the range is all the way into the negative here, but this node only does scalar. It doesn't do vector. So um, as, nothing to my knowledge. It's exactly the same thing. Someone correct me if I'm wrong, but to me, I never discovered any difference. It's just a different word in shaders. For some reason, they use the word scalar, and in like C++ programming and stuff, they use float. So it never made sense to me. It actually took me a while to figure out, but yeah. Um, we can do this. Um, So it's still just a demo of the if A is less than B, this one, oops, if if A is larger than B, or B would be 0. So here you see that the pink ones, oops, are in the negative range, since they are um, A is less than B, which is 0. So then they go pink. Did that make sense? Yeah, I'm doing a dot product of the vertex normal vector, which is pointing out from the surface like this, and the x component of that on the red here. So if that is larger than 0, which means that the surface is pointing in a little bit at least to the x direction, then I'm going to get the positive answer out of this dot product. So it's going to be something greater than 0. And if um, the x normal, if the x part of the normal, x component of normal is pointing in the other direction, the negative c and negative x, I'm going to get a negative answer out of this one, uh, because it's looking. No, I mean, if you're not wondering about it, you don't have to think about it. It's just some questions came up, so I just started making a quick one of it. So just gonna pass you some shader tips and tricks on the way, so you can, if you run into a problem later, you can. Uh, uh, yeah, could you repeat the question, please?
To basically like get more of the blue, like a gradient, but it's not a uniform gradient.
Um, I mean, you could modulate it with a texture or something.
Oh,
So you can, I mean, either like add or multiply something on the normal uh, before, or you could take the result and modulate that, um, if you would like that. So like, I don't want to get dive too deep into this one, but let's see here. See if I have a texture. Um, um, so I'm gonna remap this one from its 0 to 1 range to something like minus zero point 0.3 and zero point 0.3. And I mean, if I made a something useful out of this, I would put this in parameters. Of course, I could tweak them in a material instance. Um, oops, and I could add this here. No, oops. So I mean, shader stuff is like, to me, it's like 80% is just like adding and multiplying stuff, and then you have these kind of vector math operations. Um, I mean, this is not the perfect texture to show this, but since it's not covering the entire area. But yeah, so here's kind of modulation of that value. So you get the dot product, the value between like -1 and 1 or something, and and then you add this value which ranges between -3 and 3. So it will kind of push it around here. Yeah, I never actually did exactly this one in production, so but yeah, that's it. And if you're right with that, I'm gonna just leave this one and make a quickie on the Fresnel operator also.